So finishing up this last problem, you're just going to plug this into your calculator and you'll get out a maximum price of $100 because that's what the textbook is measured in. Part B, the last piece, asks you when is the textbook worth $80. So all you need to do is set this equation equal to 80, and then bring over the 80 so it's set equal to 0. And when you do that, you can then solve this with the quadratic formula. So you just want to plug in for A, B, and C. And if you open up the final answer solutions on the website, you can see that fully worked out for the quadratic formula. But you're just plugging in there to figure out when it is that it's actually going to be worth that price. Problem number 8. This one is asking you to solve a couple of different kinds of quadratic equations. So there's factoring, that's our primary method whenever possible of solving quadratics. But then we also have the square root property, we have the completing the square work, and then we have the quadratic formula works. So let's try one of each of those. So in order to use the square root property for problem 8a, the square root property just means that you don't have a b term or you have a binomial squared, so you're able to isolate parts of the equation simply by taking the square root. So to get started here, I'll divide both sides by 3. So we'll end up with x squared is equal to -9. And then this is where we use the square root property. We just square root both sides. But the issue here is that we're taking the square root of a negative. And so when we square root 9, we get 3. But because it's a negative, we have to bring along an I. So we'll have plus or minus the square root of 3i for part A. Then for part B, we have the completing the square problem. So it starts out as x squared plus 8x plus 10 is equal to 0. So first thing you would want to do is to check and see if an equation like this can factor, but it can't because there's nothing that multiplies to 10 that also adds to 8. So instead, for completing the square, you want to move over your constant. So this is the only way where we solve quadratic equations where we don't want all of the same terms on one side. So at this point, what we want to identify is how we can complete the trinomial, so it's a perfect square on the left-hand side. So you want to take this 8 and divide it by 2. So that's going to give you 4, and that's the number you want to square. So 4 squared is going to give me a 16 to add here. But then because I add it to one side, I also have to add it to the other side. Now I can rewrite this term as x plus 4 squared. So whatever that b term is divided by 2, as long as you've correctly squared that, you can then write it as a binomial squared. And then on the right-hand side, -10 plus 16 is 6. And so at this point, now I'm just using the square root property. So I square root both sides, and I'll end up with x plus 4 is equal to plus or minus the square root of 6. And I would just want to check whatever I take the square root of, whether or not it's something that can be further simplified. 6 doesn't have any perfect squares that divide in, so I'm stuck with it as is. And then I can just bring over -4. So I'll have -4 plus or minus the square root of 6. And then we can box that up. And that's our final answer in exact form. And you can always get decimal approximation. So if you're solving some kind of applied distance or speed or monetary problem, it makes more sense to report it in its approximation. But if you're just solving equations in general, it makes more sense to keep it in exact form so you don't lose any precision. So that's our answer to part B. And then the last quadratic equation that you would have used in the previous problem as a method for solving through is the quadratic formula. So for part C, we're using the quadratic formula to solve 3x squared minus 11x plus 1 is equal to 2. But you want to remember that in order to use the quadratic formula, you do need all of your terms on one side. So I'm going to subtract over that 2 from the right-hand side, and that's going to give me 3x squared minus 11x and then minus 1, which is equal to 0 if I subtract that 2 over from positive 1. So now I need to plug into my quadratic formula. So my -b plus or minus the square root of b squared minus 4ac all over 2a. So our -b in this case is 11 because -11 will become positive 11. So we'll have 11 plus or minus the square root of b squared, negative 11 squared will become 121. And then we'll have minus 4 times our a term, which is 3, times our c term, which is negative 1, all over 2a, which is going to become 6 in this case. So let's simplify that. We'll have 11 plus or minus the square root of, this is going to become 121. But these guys, since I have a negative and a negative, will end up becoming a positive. So I'll have 121 plus 12 over 6. And that's then going to give me 11 plus or minus the square root of 133 over 6. Now, at this point, you always want to see if you can further simplify that square root. But unfortunately, with the 133, we're kind of stuck as is. There's not further simplification that can be done. We could, again, find a decimal approximation if needed, but if we're just leaving it in exact form, this is how we would report our final answer to that equation. So that's our quadratic formula work. So let's go ahead and just talk through problem number 9, and then you're going to want to use the solutions posted on the website to help you make sure that you have the correct final answer. This one says that Jolie tracks how much she's spending on gas per month and believes the trend can be modeled by a quadratic function. So maybe she starts out the month not driving a whole lot, and then midway through the month is when she's driving the most, and then her trend kind of goes back down towards the end, or vice versa. So we have the month values. You want to think of these as your X terms, and then we have the amount of money she's spending, which are her Y terms. So it's been a little while since we've done a fit, either a linear regression fit or a quadratic regression fit in our calculators, but it's really easy to find a model. When you have your calculator out, you just want to go to L1, and in L1, you're going to put all of your X values. Then in L2, you're going to put all of your Y values. Now, if you have a TI graphing calculator, you'll end up going to Stat and then Calc, and you want to find the option that says Quad Reg. So you want to be careful not to pick the one that says Quart Reg. That's a quartic regression, so an x to the fourth, but a Quad Reg, which is an x squared. If you have a Casio, you want to input into Stat, and then when you look along the menu, there will be one that has an x squared option as far as the equations. Just pick that one. So once you do that, you'll end up with a quadratic equation. So it will give you an a, a b, and a c term. So it will say something like ax squared plus bx plus c, and then it will report the values for a, b, and c. So you're coming up with a real-world model for this data. Once you have that equation from your calculator, part B asks you about the maximum amount. Just find the vertex in that case. And then when it asks you when is she going to spend less than $40, you're just going to set your equation up in an inequality where it's less than 40. So you can check those final answers on the solutions that are linked on the website. But if you have any calculator questions, please let me know when we come back. Otherwise, you just have a couple of practice problems from your textbook relating to Chapter 4 material to take home to continue and practice and review. But they should go by pretty quickly. It's a little bit shorter than the length of problems on this study guide. So have a great weekend, you guys, and I'll see you on Monday.